Under pressure, the brain does not fail. It removes information. This removal does not feel like loss. It feels like clarity. Decisions feel faster. Judgment feels sharper. Confidence increases. This is not improvement. It is capacity reduction. A 2022 review published in Neuroscience and Biobehavioral Reviews by Brockhoff and colleagues examined how sustained perceptual and working memory load alters sensory processing in the brain. The review synthesized evidence from behavioral experiments, neuroimaging, and electrophysiological studies. Across studies, the findings were consistent. As cognitive load increases, neural responses to task-irrelevant stimuli are reduced. This reduction occurs early in sensory processing, before information reaches conscious awareness. The brain does not stop working. It suppresses information judged non-essential to the current task. The human brain operates under strict processing limits. When demand persists, resources are redistributed automatically. Neural gain increases for task-relevant signals. Neural gain decreases for peripheral and ambiguous inputs. This process does not require awareness or intention. The internal representation of the environment becomes narrower. This narrowing is not experienced as impairment. It is experienced as focus. There is less competing information. Fewer alternatives are evaluated. Uncertainty decreases. As uncertainty decreases, confidence increases. Performance remains acceptable. Outputs continue to arrive. Because outcomes appear stable, no corrective response is triggered. The signals filtered out first are weak signals, subtle deviations, early warnings, background inconsistencies. Over time, mismatch accumulates between the simplified internal model and external reality. Strain increases without visibility. Risk grows without emotional signal. When failure appears, it feels sudden, not because it formed quickly, but because perception had been narrowing for a long time. Current research does not yet explain why some systems tolerate this narrowing longer than others, or why collapse timing varies under similar pressure. What is clear is this: the brain does not collapse under pressure. It becomes efficient. And efficiency can hide failure until correction is no longer possible.